Hello and welcome to helpyourmath.com. In this video, we're going to look at solving literal equations that I literally just made up. What is a literal equation? A literal equation is an equation that contains more than one different type of variable. They can be formulas, which we looked at in the previous video, or things I just made up, which is what we're going to look at in this video. In each of these examples, we're going to solve for a. I noticed in the first example, I only have the variable a, so this is not much of a literal equation. But we can go through the motions of how we would solve a linear equation. This equation, we have a on the right-hand side, so I'm going to get a by itself there. It's being multiplied by 2 and it's being subtracted by 8. When we solve linear or literal equations, we usually will do the order of operations in reverse. So the first thing I want to inverse is that minus 8, and I want to add 8 to both sides. The addition property of equality says I'm allowed to do that. 3 plus 8 is 11, and now I have 11 equals 2 times a. Now to get a by itself, I divide both sides by 2, and I end up with 11 over 2 equals a. I'm totally fine with your answer being an improper fraction. If you think there's something wrong with it, which there's not, you could also rewrite 11 over 2 as 2 goes into 11 5 whole times with 1 left over, or in your calculator, you might get the decimal equivalent of 5.5. But for me, 11 over 2 is sufficient. Okay, so we went from a softball to a fast curved ball in like one example. What is going on here? So in this second example, not only do I have one term containing a, I have two. So what I need to do first is use factoring, because I can't have these two terms with a when I can't combine them because they're not like terms. But I can factor out an a from both terms on the left-hand side. It is the GCF. So when I factor it out, remember I divide a into each term and then I put the leftovers. A divided by a is 4, right? So if I distribute that a, I go back to that 4a, minus ab divided by a is b. And again, if I distribute the a to that second term, I would get that ab. Okay, good. So now I've taken care of the situation that I had two different terms containing a. Now I just have one term with two factors containing a. Well, a is being multiplied to this other factor, 4 minus b. To get a by itself, I want to divide by the other factor. I divide by the entire other factor, which is 4 minus b. What happens to these 4 minus b's is they cancel each other out, leaving behind a. On the other side, I can't really do anything. I'm kind of stuck because I don't have any like terms. So I just leave it as 2y over 4 minus b, and this would be my final answer. What's going on this next page? Well, you know what you should do. Pause the video. How'd that work for you? Good? Great. Let's see what's going on. On the leftmost one, here's a right here. It's being multiplied by x squared. That term is being subtracted by 5. I want to take care of that first. I'm going to add 5 to both sides. That way I isolate the term that contains my variable. I have ax squared equals, and look at that, 5 had a like term on the other side. It had 11. I can actually add 11 and 5 and get 16. Now I need to get a totally, utterly, and completely by itself. It's being multiplied by x squared. So if I divide by x squared, that will take care of that situation, right? Those cancel, we get a equals. I again have a series of things that aren't like terms. Their GCF of these three terms is 1. So we would just write 7y plus 16 over x squared. In the last video with formulas I mentioned, I could have also divided each term by x squared. So I could have written it here as 7y over x squared plus 16 over x squared. This would also be fine. I don't need to do that. You can either divide the entire side with one giant fraction bar over the x squared, or you can divide each term. That's totally up to you. I think this looks a little bit neater than this, but either one is totally correct. And our last example, we're trying to get a by itself. In the video with the formulas, because there were a lot of fractions, I suggested a property called the cross product property. Right now I can't use it because I don't have two fractions, but I can create two fractions by putting 7w over 1. Now what I can do is I can cross multiply because when we have a proportion like this, cross products are equal to each other. We would say that 7 times W times B plus 4 is equal to 1 times A minus 9. Having that one factor doesn't do anything, so I don't need to include 1 times A and 1 times negative 9. Now to get A by itself, I would need to add 9 to both sides. It doesn't look like I would have any like terms if I distributed, but as a good measure, maybe since I frequently don't distribute, maybe in this one I will. So I'm going to distribute this 7W. I would have 7 times W times B plus 7 times 4 is 28W. And then this plus 9 has no like term, so I just need to say plus 9. All of this equals A. And there we have it. I have successfully solved for A 4 different times. How'd you do with these? I'm glad to hear it. These have been examples of solving literal equations that I made up. Thank you for stopping by.